Welcome everyone back to the course on audio signal processing for music applications. In the previous two demo lectures, we introduced two audio tools, Audacity and Sonic Visualizer, which were quite useful for visualizing, editing, analyzing sounds. And in this lecture, I want to introduce the tools that have been developed specifically for this course, that have been developed using Python, and that we will very much go into detail into all the programming classes, and a lot of the demos also will be using those tools. Let me first go to the page where these tools are available. It's in a GitHub repository. I will talk about that in the programming lecture. And it has this under the directory MTG and SMS tools. In here, I will be constantly updating the tools as things are being developed and as bugs are being fixed, etc. So I recommend you to download the latest version that you can find. Okay, and here you can download a zip file, and you can follow the instructions here to compile. I don't think it's that difficult under Ubuntu, but anyway, in the programming class, I will talk about this in more detail. This is a tool that, or a set of tools that do not have sort of an icon that I can click to. So the way to access the tools is through the terminal. This is the terminal in Ubuntu. When you open the terminal, it goes to your home directory. So this is my home directory, and in it I have a few directories that I have been using for this class. When I download the SMS Tools package, it creates this directory, SMS Tools Master. So to execute the examples, I have to go into that directory. So I just type SMS. By the way, a very good key to use is the tab key, which is the autocomplete. It allows us to go quite quickly to subdirectories or to complete names of files. Okay, so this is the directory of the SMS Tools. Again, it has some subdirectories. It has the lectures, it has software, it has the sounds that I have been using, and it has a workspace directory which I recommend you to use as a place to work from. But now I want to go to the interfaces for demonstrating some of these tools, and these are within the software directory. Okay, in the software directory again there is some subdirectories, and the interface I want to use are the models interface. Okay, so I go to the models interface, and in it there is quite a few files, but there is a main interface for all the files, and that's what is called models GUI.py. Okay, so we can execute this file, and through that interface I will have access to all of them. To execute a Python file, I can just type Python and the name of the Python file. So if I type models GUI.py, it will execute this Python file. Okay, so this is an interface. So it has opened up this small interface, and in it I have access to all the different analysis synthesis tools that we will be talking about in class, like for example the DFT, the STFT, a sine model, harmonic model, stochastic model, signal plus residual, signal plus stochastic, harmonic plus residual, and harmonic plus stochastic. That's quite a lot, but we will go through all of them in both the demo and in the programming lectures. To put you an example of how these things work, let's just go, for example, to the short time Fourier transform. Okay, so this is one of the first models that we will talk about. And here we can input a file. By default, there is always something that makes sense, but let's go to another file. So this is the directory of my sounds. For example, let's use this orchestra sound. And then we can play it from here. Okay, this is a recording of a Chinese orchestra playing a fragment. And in here we have a whole bunch of parameters that we'll be using to analyze this sound. But let's just use the default parameters and click compute. Okay, and this is what it has computed. This was the original file, input sound, the X signal. And then it has analyzed the spectrogram, like the ones we're seeing in Audacity and Sonic Visualizer, but now we have actually computed with our own program, and it has a little bit more control than in Audacity and Sonic Visualizer. We can see the magnitude of the spectrogram, and also we can see the phase of the spectrogram, which we'll talk about that. And then it can inverse this process and resynthesize the original sound, output sound, the Y signal. And from the interface, we can play this output sound. Okay, so that's basically the same. So that means that this analysis synthesis has worked quite well in terms of an identity system. So that's good. Let's go to another of these models, maybe the most sophisticated one that we will do, which is called the harmonics plus stochastic representation. And again, let's maybe take another sound. Instead of this sax phrase, let's take the short version, so it's going to be quicker. Okay, and let's play it. Okay, this is a sax phrase, and again we can analyze a whole bunch of things and define many parameters. Let's just compute it. So this is a model that is more sophisticated, that more things, so it takes a little bit more time. And this is the result of this analysis. This is the input sound we just heard. This is the analysis representation we have computed that shows the harmonics and what we call the stochastic representation, and this is the synthesis. By looking at it, it's quite similar to the original. Let's just listen to that. Okay, so yes, it's quite similar. But in this analysis, what we have done is analyze two aspects of the sound. One that we call sinusoids, and let's hear that, which basically captures most of the components of what is interesting in the sound, but also has a residual, which is modeled as an stochastic signal that we can also listen to. Okay, it's quite soft, but if you pay attention, is there, and is basically the breathing part, air part of the sound that is quite relevant in many sounds. Okay, let's close this interface, and let's go to another interface that we also will be using. And so we go back by doing this. Okay, and now we are again in the main directory of the tools, and if we go to the software, and instead of going to the models interface, we go to the transformations. Okay, so we go to the transformations interface, and these are programs, algorithms, that what they do is transform the sound using the models that we just saw. And again, it has a whole bunch of transformations, and there is one which is the main interface, which is this transformations GUI. Okay, so we can execute this file by typing Python and the name of this file. Okay, so in here we have a number of possibilities to transform different sounds using the models we talked about. So for example, we can do a morph with the short time Fourier transform, we can do transformation with the sine model, transformation with the harmonic model, with the stochastic model, the harmonic plus the stochastic, and do a morph with the harmonics plus the stochastic. Let's go to the harmonics plus stochastic that we mentioned before, and let's instead of the sax phrase, let's just maybe take a shorter phrase, a sax phrase but short. Okay, we can play it. Okay, and with the default parameters, let's analyze it. Okay, this is the original sound. This is the analysis that we did. So we see the harmonics and the stochastic component and the resynthesize, which looks like what we did before. So it looks quite good. And now let's go back to the interface and we can apply some transformations. There is some values here, but let's just erase this and let's put some sort of identity parameters. So identity means that there is no change. So frequency scaling, there is a time value pairs. So at time 0, we can put frequency scaling of 1. So that means there is no scaling. And then at time 1, at the end, we just put the same thing. So that means no frequency scaling. Frequency stretching, we will do the same thing. So we'll do 0, 1, 1, 1. And time scaling, we are not going to do any time scaling. So at time 0, we will have time 0. And at time 1, we have time 1. So the time is normalized. So we can put any values, but means that we can just work also from 0 to 1. And in here, in terms of timbre preservation, let's put 0 so that it doesn't do anything. Okay, so let's apply the transformation. And now we can listen to it. Okay, we haven't done anything. But now let's do some change. For example, what can we do? So let's transpose to an octave higher, what that would mean. So it means I would just put 0, 2 and 1, 2. Okay? And now if we play that, okay, and if we do timbre preservation, so that means it tries to maintain kind of the timbre, it will sound a little bit better. Okay, but we can do other things. For example, let's do a time frequency stretching. Frequency stretching can be, let's put this back to what it was. It's kind of stretching the partials and make them and not equally spaced. So if we start, for example, starting from at time 0, we stretch it a little bit, and at time 1, and then we stretch it quite a bit more. Okay, we stretch it 1.01 and here 1.1. Let's apply this transformation, and here you see that the harmonics kind of go up, and they sort of get more separated as the frequencies go higher. Let's hear that. Okay, so we hear this kind of inharmonicity in the higher frequencies. Of course, if we make a larger larger stretching, we can have a much stronger effect. And this will be very pronounced. Okay, and we can go back to the no transformation in terms of frequency stretching, and 0, 1, 1, 1, and then let's do some time stretching. So at 0, 0, for example, let's do that at 0.5. We compress the sound. So we do much shorter, so let's say 0.25, so it's going to be half of the duration, and then at time 1 we leave it the same. So it's going to go faster at the beginning, and then it will in fact go slower towards the end. Let's hear that. Okay, and if we play it, okay, so it has gone faster at the very beginning, first half of the sound, and then the second half of the sound has slowed down. Okay, that's just a very brief example. Again, we will talk quite a bit more about these programs, these tools, and hopefully we'll have fun trying all these things out. And that was it. If you want to know more about these SMS tools, of course, follow the class. We will go quite deep into that, and you can go to this directory for the actual code. And again, all these sounds come from Freesound. So this was all. So in these 3 demo lectures of this first week, we have presented 3 tools, 3 applications, Audacity, Sonic Visualizer, and our own tools. Hopefully this gives you an overview of the type of tools that can be of use to manipulate audio, and hopefully this has given you an interest in following the course and really trying to understand what is behind this. So in the demo lectures we will just make sort of introduction to the tools and from a very practical application, but then in the programming classes and of course in the theory lectures we will go deeply in trying to understand all these things. So that's all for today, and I hope to see you in next class. Thank you.